Hello everyone. Today I am going to discuss with you a very important tool which is used in software development, which is Git. Git is one of the most important or one of the most popular version control systems available in software development market. But before looking into what exactly Git is and how it works internally, let's try to understand what exactly a version control system is. So let's get started. We will be discussing a few points like we will be discussing about what exactly is a version control and what are the types of version control systems, which include local version control system, centralized version control system, and last but not the least, distributed version control system. We will cover understanding version control and its need. Why do we need a version control system? So let's see what exactly is a version control. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. But the question is, why do we want and why there is a need to recall the versions of the files at a particular point of time in a different point of time? So why do we want to move the state of the file as it was in different points in time in history? The answer is that the software development process happens over an extended period of time. In a software development of any reasonable scale can vary from a few months to even more than 1 year or 2 years. And this is a relatively long amount of time. And during this time, the files undergo innumerable amount of changes. Okay. And there are many situations, several situations in which there is a need to look into how this file looked like at a certain point of time. For example, let's say there was a feature which was working perfectly well at a certain point of time, and after a certain point of time, when certain files undergo few changes, that particular feature which was critical in nature start working. So one of the approaches to tackle this issue is that we need to look into what change has taken place on certain files associated with that particular feature in recently. Okay, so we need to look into how what was the state of the file at a point of time when the feature was working perfectly well and how with what it is how it looks like at this present state of time when the feature is no more working. Okay, and we can look at only when we have the states recorded in the version control system. In the absence of version control system, there is no state preserved. There is only one state, which is the present state. But when you use a version control systems, all the changes what has happened to files is recorded as different states or it is or milestones, and you can basically move to the various states and you can recreate the way the file looked like at a particular point of time. And on top of that, you can also look at who changed that file so that you can have discussion with those developers to understand the context of the change. Maybe those changes were done for another purpose, but due to certain reasons that created a different issue. So we need to have the right discussions in place with persons involved in the changes so that the right decisions can be made for certain code files. Okay, so as it's correctly clearly written here that it allows you to revert selected files back to a previous state. You can also revert the entire project back to a previous state, and also you can compare changes in situations where you need to see what has changed and what has caused the issue. And also you can see who has introduced an issue. Okay, excuse me. Using a vicious also generally means that if you screw things up or lose files even, you can easily recover. This is because even if the file is deleted, the deletion also is recorded as a change, as a state, and you can roll back the state of the file to a previous state when those files were not deleted. In this way, you can recover those files. Okay. So in a nutshell, if your source code is controlled by version control, then you can be rest assured that your source code is protected to a great extent. Let's move ahead. Let's see what are the types of version control systems. On a rough scale, there are three kinds of version control systems: the local version control system, centralized version control system, and last but not the least, distributed version control system. Let's look at them one by one. What is a local version control system? As the name implies, it resides on a individual machine and it has the capability to protect the files on an individual machine. Okay, so it is installed on a machine and it has got a simple database that keeps all the changes to files under revision control. So whatever the changes different files undergo, all those changes are recorded in a database. Okay, and you can basically recreate those changes. One of the most popular VCS tool was called RCS, which is still available. Okay, and it works by keeping patch sets or the deltas or the differences between files, whatever you call it, in a special format on disk, and it can then recreate what any file looked like at any point in time by adding up all the patches. Okay, so essentially, whenever a file undergoes any change, the delta or the change set that is recorded. Okay, and this change set goes on getting recorded whenever a certain file or whenever the files gets changed. So this software essentially works on those patch sets by subtracting or adding, and using various manipulations it can recreate the file to a specific state in time. Okay, but as the name implies, it cannot collaborate. Okay, so whatever is done on one machine is opaque to developer who is working on another machine. Okay, no one can know, no one generally knows what is happening, or what the other developer is doing. So so this makes it very inefficient, because collaboration is something which is of the utmost importance in software development of any significant or reasonable scale. Okay, and the other problem is it has got a single point of failure. If the local hard disk crashes, everything is gone. The software itself is gone. So whatever it has protected definitely is gone. Okay, and so it is something that you might want to know, you might want to learn about what exactly is a local version control. But as you might have already guessed it, or you might have already understood it, it is not something which is of any practical use in the software development of any reasonable scale. So the next thing to learn is centralized version control system. Okay, and how it works is it has got a single server that contains all the version files and a number of clients or developers who check out files from that central place. Okay, for many years this has been the standard for version control. This allows collaboration which was not available in the local version control system, but it also suffers from the similar bottleneck, which is that it has got a single point of failure. The central server is the single point of failure, and if it undergoes an outage, everyone is blocked. Okay, so this again is a bottleneck which the software development of a larger scale would definitely want to avoid. The examples of centralized version control systems are SVN, CVS, and Perforce. Many of us might have worked on at least some of them, in any previous time. Okay, but today people prefer another type of version control system, which is called distributed version control system. So let's look into next. Okay, So distributed version control system is a bit different than centralized version control system. And how is it different? Here, as it is clearly mentioned here that clients don't just check out the latest snapshot of the files, rather they fully mirror the repository, including its full history. Okay. In the case of, let's go back to the previous slide. In the centralized version control system, you can see that the versions or the snap or the states of the file which the different files have undergone is only available on the central server. What a client machine checks out is the latest snapshot. So whenever a developer checks out files from a centralized version control system, they basically checks out the latest snapshot. It has got what the file looks like at present moment of time. Okay. But the client machine never gets what exact any other thing apart from this. It does not get any metadata. Okay. So let's say if the developer wants to move back into a previous state, it again has to connect to the central server, because where this that is where the information lies. Okay. But in the case of distributed version control system, whenever a developer or a client machine checks out the repository, they do not just get the latest snapshot, but rather they get the entire mirror of the repository. By mirror of the repository means all the history, all the branches, all the metadata, whatever is available on the central server becomes available on the client machine as well. So once the client machine downloads or checks out the repository, it's like that client machine has got everything which the central server has. Okay, so let's say in this diagram you can see that computer A and computer B, now they also have this all the information which this central server has, and if the need be, any of these machines can be promoted as a central server. So what it gives, it avoids a single point of failure. So let's say even if this central server goes out of service, okay, or something happens there, any of the client machine can be promoted as a central server because it has got everything which the central server has. Okay. The example of the distributed version control systems are Git, Mercurial, and Bazaar. Okay, and we'll be looking into Git specifically in this course. So this is about the distributed version control system, and you can see that it definitely has an edge over other kinds of version control systems. Okay, so we uh, so moving ahead, so let's see what we have learned uh, uh, in this duration. We have learned that local version control system takes care of only the local system, and it's not able to collaborate and has got a single point of failure. Centralized version control is a bit enhanced version of local version control. Everything is on a central server. The client machines get only the snapshot of the latest state. Okay, it is able to collaborate. Okay, which was not there in the local version control, but again it has got a single point of failure. The distributed version control is the most advanced version of the version control. The collaboration is here, and also there is not a single point of failure. Okay, as you can see, although there is a central server, but each client machine gets a full copy of the entire repository, including branches, history, etc. And if the need be, any of the client machine can be promoted as the central server. At this point, we stop this discussion, and in the next video, we will be discussing more about the internals of Git and how the Git exactly works. Till then, bye bye, take care.